Have you ever just stopped and wondered what's really going on inside the so-called mind of an AI? It can feel like pure magic. But today we're going to pull back that curtain. We're going to build an AI brain piece by piece, right from the ground up.
So this is the big question, right? It drives everything. And yeah, the things AI can do seem almost magical. But what's happening behind the scenes is actually a series of incredibly clever and, honestly, pretty intuitive ideas. Let's start with the absolute foundation, the single most important job of any modern AI.
You see, at its very core, the AI we all interact with is basically just a prediction machine. Before it can write a poem, or analyze some data, or even answer a simple question, its main job is to make a really, really good guess. So, what exactly is it trying to predict? Well, this is it. A large language model, or LLM for short, is designed to do one thing, and do it exceptionally well: predict the very next word. So if you give it the phrase, "all that glitters is not," its entire existence, all of its training, is geared towards predicting that the most likely next word is gold. Seriously, everything else that it does flows from this one simple but incredibly powerful idea.
Okay, but wait. To predict the right word, our AI has to first understand the words it's already seen. And this is where we get into the really cool stuff. How do you translate our messy, complex human language into something a machine can actually understand and work with?
So, the very first step is something called tokenization. A machine can't just read a sentence like you and I do. It needs to chop it up into the smallest, meaningful pieces it can handle. We call these tokens. You can think of it like learning the individual sounds and syllables of a language before you can start speaking in full sentences.
And here's what's so clever about this. Take a look at the word glitters. It doesn't become one token. No, it's broken into glits and ers. Why? Because the AI learns that the token ers often behaves just like ing in words like singing or doing. By seeing these little building blocks, it starts to figure out grammar all on its own without anyone ever teaching it a single rule.
So now we've got our tokens, but computers don't speak in words, they speak in math. So the next absolutely crucial step is to translate every single one of those tokens into a set of numbers, a vector. The best way to think about this is that we're giving every single word a precise location on a giant multidimensional map of meaning. And here's the key takeaway. On this map, words that have similar meanings, like king and queen, they get placed really close together. But words with totally different meanings, like king and cabbage, are put super far apart. This is how the AI starts to understand relationships between words using pure math.
But, okay, this brings up a huge problem that we humans deal with all the time: context. Words can have multiple meanings, right? So if our AI sees the token for apple, how on earth does it know if we're talking about the fruit or, one of the biggest companies in the world?
Well, the answer is pretty obvious to us. It's the other words in the sentence. Words like tasty or revenue act like giant signposts, telling our brain exactly which meaning of apple to use. The AI needs a way to do the exact same thing. And that mechanism is a truly revolutionary idea called attention. It lets the model look at the entire sentence and intelligently decide how important every other word is for understanding any single word. It learns to pay way more attention to revenue when it sees apple, and just like that, it solves the context problem. I'm not exaggerating when I say this idea completely changed the game for AI.
Okay, deep breaths. Our AI brain can now read and understand context. That's a massive step. But how does it actually learn? How does it get smarter from those mountains and mountains of text we feed it? The secret is a process called self-supervised learning. I mean, think about it. It would be literally impossible for humans to go and label the entire internet. So instead, the AI teaches itself. It uses the text to create its own little pop quizzes, learning from the data without needing any of us to supervise it. This is the key that unlocked the incredible scale of modern AI. And it's actually a pretty simple concept at its heart. The AI gets a sentence with a word missing, and its only job is to guess what goes in the blank. Now, just imagine it doing this billions and billions of times with pretty much all the text on the public internet. Over time, it's not just memorizing stuff. It's learning the deep patterns, the grammar, and even the logic of human language, all by itself.
So the architecture that brings all of this together, the tokenization, the vectors, the self-supervised learning, and especially that game-changing attention mechanism, is called the transformer. It's the blueprint, the actual engine design that allows an AI to process all this info and make its predictions.
And honestly, this is the perfect way to think about it. The LLM is the final product you see and use. It's the car.
But the transformer, that's the revolutionary engine inside that makes the whole thing go.
All right, so now we have our base model. It's this powerful generalist brain that knows a little bit about pretty much everything it's read on the internet. But a generalist isn't always what you need, right? To make it truly useful, we have to turn it into an expert.
And we do that through something called fine-tuning. We take our general-purpose model and we give it a much smaller, really specialized data set to learn from. So for example, we could feed it nothing but medical textbooks to make it an expert in medical diagnoses, or financial reports to make it an expert in market analysis.
But fine-tuning doesn't solve one huge problem. An AI's knowledge is basically frozen in time at the end of its training. And that's where a technique called RAG comes in. You can think of it like giving the AI a library card and a live internet connection. Before it answers your question, it can go look up the very latest information, making sure its knowledge is always fresh and relevant.
You know, the biggest trends in AI right now isn't just about making models bigger. It's actually about making them way more efficient. How can we get the same, or maybe even better performance out of smaller, faster, and more specialized models?
This table really breaks it down nicely. Large language models are these amazing generalists, but small language models, or SLMs, they're being trained on specific company data to become super efficient experts at just one particular job, like being a customer service bot. They end up being smaller, cheaper, and way faster for that one specific task. So how do you actually shrink an AI? Well, two popular ways are distillation, where a big, powerful teacher model basically trains a smaller student model to get the same results. It's like passing on its wisdom in a much more compact form. And the other is quantization, which is kind of like compressing a really high-resolution image file. You just reduce the precision of the numbers inside the AI's brain to make it smaller and faster without losing much quality.
So there you have it. From a simple next-word predictor all the way to a specialized expert, we've basically just built the brain of a modern AI. And that leaves us with a pretty fascinating final question. Now that we know how to build them and how to teach them, what values, what knowledge, and what goals should we be giving them next?